In this video, we will break down how Davinci Resolve can be used by 3D artists. For this, we will discuss how to bring our ACES renderings to Resolve using multi-channel EXRs and also explore various other tips and tricks to make the whole workflow more efficient. So Davinci Resolve is used by more and more 3D artists nowadays. In this video here, I want to break down my personal workflow of how to bring ACEScg multi-channel EXR renderings into Davinci Resolve so we can make use of its amazing features in here. So we can do our final editing in here, for example, and especially we can do our final color grading. And that's also where Davinci Resolve here is known the most for its amazing color grading tools. And there's even a whole compositing software called Fusion directly built into Davinci Resolve. And that's basically an alternative to compositing software such as Nuke. So you can use that to build some very complex compositing tasks in here. And the best of it is that Davinci Resolve is basically free to use. So all of the features that I show you in this video here are achievable with the free version. So all of this makes Davinci Resolve a really compelling offer for 3D artists to integrate this in your workflow. In this video here, we will break down how we can make the best use of this. So for the 3D software, I personally am using 3ds Max and V-Ray. But it really doesn't matter which software and which rendering you're using. And I'm just going to use 3ds Max and V-Ray now as an example, but you can transfer all of this here to your 3D software of choice. So I'm going to be using this scene here as an example that I built recently for a rendering challenge that I took part in. And if you want to know how this scene here was done and how it turned out, and you want to watch a whole breakdown, you can find that in my channel. But the key point why I want to use it for this video in here is that it's rendered in ACES, and it's also a little bit more complex. So it has a whole environment, it has atmospheric fog, it has character, subsurface scattering, and so on. And we're going to save out all of this as multi-channel EXR and then bring that into Davinci Resolve, do multi-pass compositing and then color grading and see how the whole workflow here basically works. So here's what we would see in the render view, but before we're able to save out this image or image sequence and send that to Davinci Resolve, let's first talk about some basics. So first of all, I'm using ACES for rendering this project. So I switched my RGB primaries here to ACEScg and the color management. And I also loaded the OCR configuration file in my frame buffer. And in my case, I use the sRGB view transform because that fits the best to my monitor. And I'm not going to go into the details of how to set up ACEScg because that's kind of V-Ray specific. So you would need to find out how this works in your software of choice. But if you want to know for V-Ray, I have multiple detailed tutorials about this whole process in my channel. So after we're sure that we use the correct ACES workflow, let's talk about the render elements. And what you can see here at the moment is the RGB color, the beauty layer basically. But internally, this image here consists out of different elements or can be broken into different elements. That would be, for example, the lighting, the global illumination, specular, reflection, refraction, self-illumination, and so on. And all of those we want to bring into Davinci Resolve, combine them, and then get this result here. And since we combined this from the individual elements, we're then able to do additional adjustments here on the base elements. For example, we can go in and boost our subsurface scattering, or we can change our refraction and so on. We have a lot of flexibility doing so then. So in terms of what render elements are needed, that really depends on your scene. So for example, this scene here uses a lot of fog. So I need a render element here for the fog, which is this atmosphere render element, in order to separate the fog from everything else. But if your scene doesn't have any fog, you also wouldn't really need this element. So it really depends on whatever scene you have, and you would need to make sure that just all the render elements that are required to rebuild this beauty layer would be exported also as well. So within V-Ray, you can set up your render elements in the render settings. I just went in and selected all of the render elements that I need to replicate this beauty layer in here. And since I use a denoiser for my final rendering, you also want to make sure that your different render elements would also be denoised. And in V-Ray, you can set this up here by enabling this checkbox. Because otherwise, if you didn't denoise your render elements as well, if you reassemble them, your end result would look quite quite noisy. So just make sure that your render elements also would be denoised. And additionally to those render elements which are required to reassemble the beauty color, I also went in and added some additional elements like those Cryptomattes here. So those Cryptomattes I set up to select different types of objects. Here I select by material, I select by node, and I select by layer. And then later on in Fusion, you're able then to use those Cryptomattes here to select several parts of your scene. For example, you can go in and select this character here and say, okay, I want this character to be brighter or darker. Or you can select this whole building and change its hue and so on. You're really very flexible with those Cryptomattes, and you don't need to define in advance which kind of parts of the scene you can select. You just throw in those Cryptomattes, and later on in Fusion, you can just on the fly decide, okay, I want to pick this object or that object, and so on, and do some additional color adjustments on that. So it's always a good practice to throw in those Cryptomattes in here, because this can later on save you a lot of trouble down the line. So the V-Ray frame buffer is quite advanced, and it also allows to do some additional color adjustments here directly in the frame buffer. If I disable them, this is basically how the image would look like, the raw rendering. And this is with some additional color adjustments that I applied on the top. And if we want to also bring those over to Davinci Resolve, we would have to export it, because those would not be applied here to the different render elements. So if we reassemble all of those elements here, we would end up with this result. So we would have to find some way to export those in here. Luckily, the step in V-Ray is quite simple. You just need to go to the display correction tab, switch this one here to none to not bake any of those adjustments here into the lookup table that we're going to export now. And now we will right click and say save all color corrections as LUT. And then we just can call this here LUT, for example. It will save this as a cube file in here. So now we would be ready to render everything into a multi-channel EXR. And within V-Ray, you can just do that in the V-Ray tab here and enable this V-Ray raw image file option in the frame buffer settings. And then inside you can just select the file type EXR. And I normally also tend to use this save virtual frame buffer color corrections to the RGB channel, so that basically those kind of color corrections here would be baked into the RGB color channel of the EXR. And then we have it easier to compare it to once we assemble all of the layers together. So now let's just submit it for rendering and see what we will get out. So here you can see the render sequence, and you can also see that the file size for each of those frames here gets already quite big, roughly like 160 megabytes per frame. And the reason for that is that all of the different render elements have been saved out in one single EXR file. That's why it's called multi-channel EXR files. We can also verify that by loading the sequence here into a player. For example, this here is the Chaos Cosmos player, which allows to read out multi-channel EXR files. And then you can check inside here that all of the different layers have been saved out. For example, I can check the specular layer in here, or I could check the atmosphere layer here for the fog, and so on. So to just make sure that all of the different render layers are saved correctly in the EXR file. You also notice that the colors here look quite different. That's because we don't have the appropriate lookup table loaded in the player to make the ACEScg images appear correctly on our monitor. And this we can do here in the lookup table tab. So once I loaded the correct lookup table for my ACEScg rendering, this also appears correctly on my monitor in here. You will also notice that there's a little bit of noise in the rendering here. And that's because we load the default layer. So the default layer, when V-Ray saves out the image, is always the one that doesn't really have any denoising happening. So if we want to see our finished result, we have to change this to the effects result layer. Once you do this, you can see that this noise here disappears. And also we have this kind of glow, which is added basically as a post effect on top of everything. So this is how our finished rendering should look like reassembled in Davinci Resolve then. So I will also make this whole image sequence available on my Patreon. So if you're one of my Patreon, you can download this image sequence and then also try in Davinci Resolve to make your own grading and reassemble all of the different passes together to get a final and nice looking result. So here we're finally in Davinci Resolve, and I created already a new empty project. Let's go inside and set the project settings. I already went in and set the correct resolution and then also the correct frame rate in here. Now we're ready to jump into the color management section and then start to play with those settings in here. So by default, the color science is set to Davinci YRGB, which is basically unmanaged. So we are dealing with ACEScg renderings. So we need some kind of color management, and there's ACEScc and ACEScct here available. I don't really want to go into the details. Let's just use ACEScc. ACEScct is just a further development of ACEScc with some tiny variations, which in our case don't really make a big difference. So let's just use ACEScc. And then let's see what kind of settings we can use in here. So first you can choose different ACES version, with 1.3 being the most recent one. And if you notice closely in V-Ray, I set up ACES 1.2 because I didn't really have any later configuration file available. But nonetheless, let's just use ACES 1.3 because it doesn't really make any difference in our case in here. So we are exporting ACEScg renderings from our render software. And here the color science is set to ACEScc. And you might wonder what the difference is. So ACEScc is logarithmic, and also all of the color grading, everything that's happening in Davinci Resolve is happening in a logarithmic environment. And that's also why there is no ACEScg available in here. So we just have these logarithmic workspaces or color sciences. And that's why when we import our ACEScg renderings, Davinci Resolve will also assume that those are logarithmic, while ACEScg are linear in nature. So what we have to do is to define an input transform. And here we just can choose that everything that we feed into Davinci Resolve will be treated as ACEScg. So let's just select this. And we also have to choose an output transform. And here, in order to make this match exactly to what we had visible in our V-Ray frame buffer, where we had the view transform set to sRGB, we will also choose here the output transform to be sRGB. And now let's just save this, and we can now try to import our sequence and see if everything looks correct. For this, let's just right click in our media pool, import media, and then just select all of our renderings. And then we can just direct them into our timeline down here. And you can see it looks now correct. We have exactly the same result that we had in our rendering software. So that's basically a very good start. So one thing you will probably notice is that the playback is not really the fastest in Davinci Resolve. And that's because it doesn't really seem to handle multi-channel EXRs very smart, because it seems to always load the entire data, even though currently it's just displaying the RGB color. It seems to always load everything, and that kind of seems to make it quite slow. But later on, we can work around this annoyance by using caching. And this way we can get buttery smooth playback again. But now anyway, first of all, we have to split up here our rendering into the different channels, reassemble those in Fusion, and then later on we can take care about the smooth playback in here. So now we want to split up and reassemble our multi-channel EXR, and we can do that in the Fusion page. So if we click on here, you can see our whole view changes, and unfortunately also our color change. So if we head back to the edit page, you can see we have those colors which are correct. And then also in the color correction page, we have the same colors. So those are also correct. But Fusion is kind of in its own world, and that can sometimes be a little bit of an annoyance. So our first goal would be to make the colors match. And what we can see here is that we have two different nodes. One is the media in, one is the media out node. And in our media in node, we're just loading our EXR, and we can see which channels we are loading in here. At the moment, we just use the red, green, and blue and alpha channel. We don't really load any of the other channels in here. Then we have the media out node, and this one then transfers what we have in Fusion to our edit and color page as well. And now we have the problem, as I said, that the colors don't really match. And the reason for that is that, first of all, we have here this view LUT enabled by default, which doesn't really work in our case. So we can disable this view LUT. And then we have to build our own LUT. And let's just add here a new ACES transform node by just pressing Shift space. We can add this ACES transform node. This just adds this here into the graph. And now we don't want to put this here in between the media in and media out node, but we want to put this behind the media out node so that basically our data is not really being messed with. We just have this here as a viewer basically. So let's just connect this one into the ACES transform and then just load this here in our viewer. At the moment, nothing is really happening because we first would need to change our input and output transform. And here we have to do it basically the same way like we did already in the project settings. So let's just use the ACEScg as the input color space and then the sRGB as the output color space. And once we have that, you can see that we have now the colors which are matching with our edit and color page. So if I switch back now to the edit page, you will see we have the same kind of colors in here. If I switch back to the Fusion page, unfortunately, you always need to load this here in your viewer again. And then you can see that we have now the matching colors basically. So this is a little bit of an annoying workaround that currently exists. But if you know any better solution, be sure to let me know in the comments. So now if we head over to the media in node, you can see if we click on this channels node, which kind of channels are being loaded. At the moment, we just load the R, G, and B channel. And if you slide down here, you can see this is all the channels that come with the Multichannel EXR. And somehow they all get split up into R, G, and B channel. So in our case, we need to load here the effects result R, effects result G, and then the effects result B channel. And this way we make sure that we also have here our denoised image and also our lens effects applied correctly. So now we would be ready to split our EXR in multiple channels. And you can do that manually or with a script. And doing it manually is very tedious because you would need to copy this node and then always select the different channels in here. That's very annoying. So I just installed a script which is called the Reactor Suite for Davinci Resolve or Fusion. And you can find that easily when you use Google. And once you install that, you can open here Reactor. And once that's loaded, it's basically a collection of several very useful scripts that you can use. I only use two of them at the moment. One would be Cryptomattes here, so enable this one. And then I also use this HOS split EXR Ultra script. So that's the one that we're going to be using now in order to split up our EXR into multiple channels. So in order to do that, let's just right click here on this node and then just go to script and then HOS split EXR Ultra. And then once we do this, we can just use those settings in here, just do that horizontally and just press the run and close button. And after it's done, you can see all of those here have now been assembled, maybe not in the most smart way. Let's just use this one here to not have them overlaying with the other stuff. You can see now we have basically all of these different nodes in here, which basically are exactly the same like this media in node. Just the difference is that they always use the correct channels in here. So for example, if I use my atmosphere layer and I go to a channels pad, I just have this atmosphere R, G, and B already assigned in here. And that's basically quite good. So that's exactly what we need. So now let's just reorganize this a little bit. So now I just went in and reassembled this a little bit, and I put all of the render elements that I would need to combine down here. And then up here, I have some of the other elements which I don't need for the moment, like the Cryptomattes and so on. And now we would need to combine all of those together in here. So for this, we're going to be using the channel boolean, and you can get this by just clicking on this button. And now let's check what we have here in those different layers. This would be the lighting, the GI, specular, reflection, refraction, and so on. So we would need to combine them, and let's use the add operation in the channel boolean. So at the moment it's set to copy. Let's switch this to add to basically add both of them together. So let's put the lighting in this yellow part in here, and then the GI in the green part. And you can see the lighting looks like this, the GI looks like this, and both together now look like this. And that's an easy way how to combine them. So if I hover with a mouse over the image in here, you can check those values down here. And you will also notice that the alpha channel, has a value of 2. And that's not really what we want. This can cause some issues down the line. So for the alpha here, let's just use the do nothing operation. And if I now hover over the image, you can see the alpha channel, or the A here, has a value of 1, and that's basically what we want. So now we would just need to go in and copy this channel boolean to here, and then pipe this into here, and then the specular into this one. And now you can see we also added the specular. You basically would need to do that for all of those elements. So let me just do that now, and I will speed up the step in order to save some time. So now we added all of the different render elements here on top of each other. And as you can see, we slowly start to build up here our final image. So now in order to compare both, let's copy the ACES transform. Let's also connect this into the ACES transform in here. And now we can compare both of them here. And we can see that the colors are not really matching. We have kind of similar brightness, but the colors are off. And the reason for that is that we didn't really load yet our lookup table that we exported from our frame buffer previously. And this we have to do now. So for this, let's select here the last channel boolean. Let's add the lookup table. And once we added this here into the graph, let's load our lookup table that we exported earlier from the V-Ray frame buffer. And once I load this in, you can see the colors changed. And if I now switch back and forth between those two different nodes in here, you can see that now the colors almost match perfectly. The only difference we have is that in our rendering from the frame buffer, we had this kind of vignette effect here on the edge, where I added this kind of vignette in the frame buffer, and this didn't really transfer over in our lookup table because this just changes the colors. It doesn't multiply some vignette effect in there basically. So that's also easy to change. We have here already prepared a vignette node, which I already set in with the correct settings. Let's put this also in between here. And now if we switch back and forth between those two different layers in here, you can see that it almost looks pretty much the same, with the exception that all of those ones here are composed out of the different or individual elements. And this has a lot of advantages. For example, we can now go in and add a color corrector for each of the different elements in here. For example, we can then boost our self-illumination layer, or we can go into our fog layer, also add some color correction here, increase that or decrease that, or change the gamma and so on. So you can see you're very flexible then to make some additional adjustments here using the multi-channel EXR compositing. And this really gives you a lot of flexibility even after you finished your rendering. So now we only have to take care of our media out node in here. So we set up this whole graph, but it basically leads to nowhere because exported or handed over here to the edit or color page is just the media out node. And this is still linked here to our initial effects results elements. So we have to then use the file LUT and then pipe this into the media out. And then we are now exporting basically all of those multiple channels in here. So if we now go to our edit page, you can see that now we have this result in here. And if I now play back, you can see it will take a little bit longer time because he has to assemble the image here from all of the different render elements. But now we basically use here our multi-channel EXR, which is split up into the different channels. We're able to do now some adjustments here in the Fusion page, do additional color adjustments, or we can head on over to the color page and do our additional color grading in here. But before we do that, let's first take care of our playback speed. And you can see that if I try to play this back now in real time, it will be very slow because he has to recompose all of this from the different render elements for each frame. And the solution for that is called caching. And for this, we have to enable that in Davinci Resolve. And we just go to the playback options, and then we just go to the render cache and use the user option here. So once I enable this, then I also need to make sure that the render cache fusion output here is set to on. So let's put this here to on. And once we do this, you can see that there will be this kind of blue bar which is slowly building up, but we have to make sure that we use the right kind of cache. And by the right kind of cache, I mean having the right amount of bit depth or the right amount of data that can be stored in there, because we don't want to store our cache in a low dynamic range format, because otherwise our color adjustments wouldn't look nice. So let's just go to our project settings, and then here I think down in the master settings, you can choose the render cache format. And I think best would be to use uncompressed 16-bit float HDR. But if you can't really use that, because this will take quite a lot of space, you could also go with any other HDR format, for example, this one here. And once we save this, let's just wait until here the cache is fully loaded. So now that the caching is finished, you can see I can play and scrub through here in real time, and everything runs very, very smoothly now. So it's always good to use the caching feature here when dealing with multi-channel EXRs or more complex fusion compositing in here. So now we can also head over to our color adjustment page and finally now use all of the amazing color grading tools that Davinci Resolve here offers. I'm not going to go into the details because this tutorial here is more meant as a technical breakdown on how you are able to do the color grading. We're not really going to do some kind of complex color grading in here. Just be aware that you can, for example, change then the exposure here, or you can change the curves, or just adjust all of these different tools that you can find in here and play around with it a lot. So as a last step, I want to talk about the Cryptomattes. And the Cryptomattes are super useful to make some localized adjustments afterwards. So let's say we find that we want to change the brightness of this character here, for example. We can easily do that using the Cryptomattes without having to go back to 3D and change that. So for using the Cryptomattes, you have to go back to your Fusion page. This one here is our Multichannel EXR Fusion project, where we split already all the channels into the different components. But in order to use the Cryptomattes, it's much better to use basically the collapsed EXR. And for this, let's just add here a new loader into the scene and then just load the same EXR sequence again that has all the channels basically combined. Now, if you have the reactor script suite installed here, which you can verify by just heading over to the scripts reactor and then open reactor, you can make sure that you select the Cryptomatte script, which you can find by just scrolling down here a little bit. So this one has to be enabled, and once you enable this, you can then load some Cryptomatte node here into your node graph. So now you would need to connect this one into the Cryptomatte. And now if you preview here the Cryptomatte, you can see some kind of weird colors that are showing up already. And there's 3 different Cryptomattes which I exported. I have Cryptomattes by layer, I have Cryptomattes by material, so we could choose basically everything that has the same material, or I have Cryptomattes by node, so that's just the individual objects that I have in my 3D scene. There are also different kind of view modes. So at the moment this one is set to colors. I normally like to use this edges mode in here, because then you can quite clearly see which kind of objects you can select. So everything that has like this kind of bluish outline can be selected. So in order to select our character, basically, we would just go to the layer node, and then you can see there's this kind of red crosshair here. We can just hover this over the part that we want to select. So for example, a character here, and then just press add. And once you do this, you can see that the character now gets this kind of like yellowish tint in here. And this means it has been selected. So if we switch this one here to matte, you will also see that there is now a matte generated, which looks very good with the motion blur and everything even. And this can now be used in order to do some color grading on the character. So let's say we can add here a simple color correction in our node graph. And then we can output here this Cryptomatte and feed that here into this blue part of the color correction, which means we will use it as a mask. Let's just preview our last node in here again. And now we can go in and change, for example, the gain of this character, or we can lift it or increase the gamma and so on. You can see we can make some really crazy adjustments here on this character on the fly without having a predefined mask that we output from 3D. We just throw in the Cryptomattes and then we're able on the fly to just select whatever object we want in our scene. So let's just say we want to increase here the gain of this character a bit, and then also maybe the contrast. And now you can see basically with this node, you can easily adjust some parts here of this image. Let's add a different Cryptomatte. For example, let's connect this one in here and preview this Cryptomatte. So let's say we want to select all of our characters in here, all of our zombies. We can do that also maybe in the, let's say, layer matte. We have to clear that because our character is still in there because we copied our previous Cryptomatte in here. And then we can just go in and select this character in here, and this would select the whole layer of this character. So let's move to, for example, this one. We can then add other parts in here. So let's say we want to add this character in here. You can see because this character is also in the same layer in my 3D scene, it will also be selected. Or if I select this one, it will also select the other character back there because they're all part of the same layer. And now we have basically all of our zombie characters here selected, and we can add like a new color correction node and then just feed this inside the blue part here of this color correction node, preview our last node again, and then we can go in and make some adjustments for all of those characters. So you can see it really gives you a lot of flexibility to do some after grading basically and be able to just fine-tune your image exactly the way you want it. So now let's summarize this again. So we first had to fusion and split up our multi-channel EXR into its several channels and recombine them so that we're able to do some individual color adjustments for each of the individual channels in here. And then we're able to do Cryptomatte adjustments for individual parts in here. And then after we have our overall look in place, we can then move on to the color page where we're then able to do lots of different effects, for example, and use all of the different tools that Davinci Resolve offers here to do our final color adjustments. And then we will use caching in order for some smooth playback so that we can scrub through our whole animation here in real time and be able to see how everything looks and behaves. So this currently breaks down my workflow that I currently use for ACEScg multi-channel EXR renderings and how to bring them to Davinci Resolve and Fusion. And I hope you learned something from that. And if you have some idea about how to make some parts of this workflow better, I'm always all ears. Let me know how you would handle certain situations because I'm also quite new to use Davinci Resolve. So on my Patreon, you will be able to download this whole render sequence and recreate everything that you learned in this tutorial here basically, and also make your own grading and practice this. Also, you can watch a whole course on car rendering and you can download all the scene files for all of my other tutorials. So check this out if that's interesting for you. Otherwise, see you next tutorial. Take care and see you soon.